Hello students, Callan Bentley here, and I'm on board the drilling vessel Chikyu, and we're currently above the Japan Trench, coring through the plate boundary in an attempt to better understand how giant earthquakes occur at plate boundary subduction zone faults that end up making tsunamis and causing hazard for people who live in coastal communities. So I've got a series of questions that you sent me, and I'm going to answer those questions now. First off are a series of career questions. What made me want to be a geologist and what was my inspiration? I always really enjoyed being outside and connecting with nature. My first passion was not geology. It was, in fact, insects and snakes and frogs and small little creepy crawly critters. And so for a long time, and even going into my first year of college, I figured I would be a biologist studying life. But then I took a geology class kind of by accident, and I did well in it, and I learned a lot, and I found it fascinating. And so I thought maybe I'll be a geologist instead. Turns out that the geology department at my college had a lot more field trips than the biology department, and I really liked that. And I also really liked the size of the geology department. It was small compared to the very large biology department, so it felt a little more cozy, like a family. How long have I been a geology teacher? Several decades now. So basically I graduated from college in 1996, and I worked in informal education, and I was in the United States Peace Corps, and I taught in the Washington, D.C. public school system, and then I went to graduate school. And basically since 2004, 2005, I've been teaching at the college level. So approaching 20 years. What's my favorite geology trip and why? Well, I always like going new places and seeing new rocks, especially those that kind of stretch the envelope for me in terms of thinking about what's possible in the real world. One that was really memorable for me was going and looking at some of the oldest rocks on Earth in the Barberton Greenstone Belt in South Africa. That was a very powerful week-long field trip leading up to a major geology conference called the International Geological Congress that was held in South Africa that year. So I'm really glad I got to go and see some of those really ancient rocks, including some that basically don't form on Earth anymore. They're rocks that form under circumstances that no longer exist on our planet, and so it's kind of neat to see extinct rocks. What's my favorite research in geology? So this might mean area of study. I'm really interested in two things. One is how rocks deform. So how we take a rock, say with a fossil in it or something like that, and then we shear it out so that fossil gets distorted and stretched out. Maybe you've seen mirrors that are slightly bent or curved, and they end up changing the shape of your face so it gets stretched out or squashed. Basically, rocks can pull that trick too, except it's not just a trick. They really do change their shape, and so that's interesting to me. The second thing that I'm really interested in is the long-term evolution of different places that I've become familiar with, like the Appalachian Mountains in the United States, and the Rocky Mountains, and coastal California. Those are three areas that I'm particularly interested in. All right, why is geology an important study field, and is it worth getting involved in geological studies? Well, geology is the study of the Earth, right? So if you are an Earthling, if you live on the Earth, then you should know something about this world that you live on. So I feel like it's very important for people who are resident on this planet to know something about how it works. I mean, that's really emphasized with this current expedition, where we're trying to save people's lives, right? We're trying to understand better how these major tsunami-causing thrust faults end up accumulating stress and then releasing that stress very quickly, causing tsunamis. So I think it's very, very important if you care about preserving people's lives. The final question I have is, what sort of student or adult tends to make an excellent geologist? Well, I would say it's somebody who's curious, somebody who is meticulous, like that you pay attention to details. It's funny because like some details are worth paying attention to and some are sort of extraneous and not really worth paying attention to. So one of the things that comes with education is figuring out which details are worth your attention. Once those become apparent, I think it's really important to key into them and to constantly be looking for them. Another thing that's really important in terms of a characteristic among geologists is to be comfortable not knowing the answer. So oftentimes we'll make an observation about nature, and then the question is, why does that observation exist? Why is that rock, say, or that landscape that particular way? And so one of the ways that we kind of cope with that is we come up with multiple ideas about why things are the way they are. We call these ideas hypotheses. And geologists are very comfortable with multiple working hypotheses rattling around in our head at the same time. So we can have more than one explanation for things. And that's very different from some other areas of sort of human understanding, where people know that there's one story, and no matter what reality tells them, that one story is what they stick with. But in geology, we let reality guide us, and then we come up with multiple different stories. And then eventually we rule out some of those stories, trying to knock them down with new information, new data. If we knock down a story with data, in other words, if we prove it wrong, then we don't need to think about it anymore. If, on the other hand, we don't succeed in knocking down a story, if it survives some new information, it doesn't necessarily mean it's correct, right? Some further information down the line someday might disprove our story, and we have to be comfortable with that, all right? So our understanding is anchored in a very primary, fundamental way on information that we can quantitatively measure from the real world. So if you're comfortable with that, you might make a good geologist.